everyone, my name is Timothy Lee Grant, and today I decided that I'm going to start a new series on this YouTube channel. So, right now I have three different series. The first one is I do LeetCoding. So, I try to understand LeetCode, I try to get better. Right now, I'm not very good at LeetCode, so I'm kind of documenting that process of moving forward in my LeetCoding experience, right? And hopefully being able to give some suggestions on, okay, like I made this mistake in LeetCode that cost me a lot of time. How would I do things differently, etc. Right? Give some tricks for people to improve themselves so that they don't need to waste any time, or so that they can be more direct in their approach for LeetCode. The other project that I am doing, project series that I'm doing on YouTube is JavaScript. So as of right now, I don't know about the entire domain which JavaScript lives in. So that's web development, that is client server interaction, stuff like that. My degree is electrical and computer engineering. I have a minor in computer science, but my main degree is more focused on kind of like the embedded systems stuff. So I really want to learn software development. I really want to get into that field, right? So that's why I said, okay, well, I'm gonna make my own projects. I'm gonna try to gain those skills. I'm gonna try to move forward in it. And so that JavaScript uh, series is kind of a introduction for myself, but also kind of like showcasing the journey and kind of playing with all of the concepts. Again, the two projects, the JavaScript, and then I also do the Java. So that's the third one, is Java. So both of those are kind of just, like playing around, more relaxed, more just enjoying things, like trying to learn, trying to be curious, and pick up new skills, right? So today I am thinking I am going to be doing machine learning. So that's also something that's super interesting. So I I actually already started. I made a video about machine learning. Like, it was supposed to be the number one of this YouTube series, so I made that a few hours ago. But in that video, I got a little bit depressed, and I, in my YouTube videos, I really do want to showcase kind of authentic development. Like, I don't mean software development, but I mean progression in uh, the journey of becoming a software engineer. And so I do want to showcase my failures. I do showcase failures, but I feel like that one got a little bit too uh, like depressing. And there's kind of a line that I don't want to go too depressing, right? Like my goal with these videos isn't to bring people's energy down. I want to encourage people, and I want to, yeah, I can show my failures, right? Like all my LeetCoding videos, I always seem like I just keep running into a wall, right? And I post those because I want to showcase, like, hey, like I do fail a lot, and then hopefully, eventually I'll be able to get it and become a lot better at it and show that progression, and maybe encourage people, right? Like, so yeah. Anyways, I decided, okay, maybe I uploaded the video, but I don't think I'll it's private right now, but I don't think I'll actually post it. But anyways, so that means today, this video here is the first video of that series. So let me kind of introduce like what I'm doing. So first I will minimize myself, and then, oh, and the other thing with these videos is with my JavaScript, my Java, and now with the machine learning, this is more like conversational. This is more kind of relaxed. As I said, like playing with it, trying to have a good time learning, right? Like that's the point of everything. Um, so anyways, here we go. So this is the I'm in my machine learning kind of folder, and I just went to ChatGPT or Copilot and asked it, hey, can you give me uh, can you give me a project essentially, with the data sets, the test, the train, and then the shell script. And can you give this to me? And it did. It said, hey, this is this, or put this in your test, put this in your train, put this in, and it gave me like just output the code. Now, I tried to run it and I hit a ton of errors. And that was what the last video was. Like I hit ton of errors. It wasn't compiling, nothing was working, and I was just like, "Oh my goodness, this is awful." Um so in this video, or in the last video, I finally got it to work and I was like, "Okay." So I'll showcase like kind of like what it's doing right now, and then obviously I have no idea how this is working or if it's actually working. And so that's what this video is going to be, is, okay, I got it to compile, even though Python doesn't actually compile, but you know what I mean. It compiles, it's not breaking, but I don't know what's going on. I don't know, like, so that's kind of what this video is going to be about, is like, okay, now that it compiles, what's actually happening, and that's going to be this investigation. So first, let me show you kind of like if I run it. So I'm doing Python, and then I'm just doing my train model. So if you notice here in my shell script, I have like this command here, which is the exact same thing that I'm inputting here. So I'm only running one of these. So this is training on this like model and using this data set, this model, that data set. So I'm only doing one of them, right? So let's run this and I'll show you what happens. Still going. So anyways, yeah, like I think that this is going to be a really interesting kind of project. Obviously, machine learning is very interesting, like from a mathematical point of view. And also it's, I've already learned a lot regarding like software development. Hey, finished. Okay, let me continue that idea and then we'll investigate this. But anyways, I already learned a lot regarding kind of software engineering principles, or not principles, that's the wrong word, but just like concepts that are important. Namely, like setting up this virtual environment. That took me a long. I didn't know what that was. I was like, "What's going on here?" Um, so I'll talk about the virtual environment once we get more into the investigation. But I was really happy that like uh, okay, cool, I'm learning machine learning, but I'm also learning a lot of the concepts that are transferable from this project over to like software development. So, and I really am trying to, that's what I'm doing with my projects, is trying to gain skills to be able to do software development, because as I said, like my job and my degree are more firmware. So think electrical engineer. It's the combination between like electrical engineering and hardware, electrical engineering and computer engineering. So it's writing software. It's not really it's like writing C, but you're more talking to like registers or trying to write a driver for a specific communication that's going to be going over like the physical layer. So you're not abstracting it away into the Ethernet layer, or whatever, the OSI model, right? Like the different. You're not doing that. You're like, it's called bit banging, right? Like bit banging. But anyway, so like that's more of kind of what I do, which is very different than world of like software development. And so with these projects, I'm really trying to hone my skills and even just gain the skills of software development. So let us come here. Now, this is our graph. So it is the training loss over epochs, okay? The training loss, and then, so it starts up here, and then at the first epoch, the training loss goes down, 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 and down. So that's kind of what we're expecting. So I think what this is meaning is I have training data, and I'm applying some machine learning algorithm or adjusting parameters. I don't know how, but I'm doing some kind of training, okay? And then I'm seeing how my loss function is kind of reacting over each epoch. So I'm not quite sure what an epoch is, and I do know loss function, but I'm not sure about epoch. I think that just means like how many times I run my uh iterator or something. I don't know. But anyways, so that's kind of like where I'm at right now is I got it to run, something comes out and it doesn't crash. I have no idea because I didn't write this code. This was Copilot. This was ChatGPT, right? Well, so it was Copilot who did it. But this Copilot, not I don't have Copilot on my IDE, so that's what I mean. Anyways, so it it wrote all these. Now let's kind of investigate what's going on. So, anyways, I'm gonna start with my shell script right here. So this is kind of where we enter the project. This is the script that runs the executables of what we're going to do. And so let's just focus on this one for now, because if we're looking at all this, it's like overwhelming, and let's just focus on one thing. Let's try to understand one thing right now. So, okay, cool. So we're running Python, okay, and this specific script, okay, the train.py, that is right here, okay, and now with Python, I never really messed around with what arguments you can and can't, like how do you pass in arguments? Quite interesting. This is a new point, right? Like, as I said, with when I'm doing my projects, I'm always trying to keep an eye out for new things that I didn't know about, or gaps in my knowledge, or stuff that is something that I feel like is important, right? And I also want to kind of like say them out loud and not be embarrassed by it, because obviously if I understand from like C or something like C++, right? Like it's very basic to pass in parameters to your program. That's like the argc, argv, whatever it is, right? That you can pass in as parameters over into your function. I understand. So for me to even say like, oh, I didn't even know that you could do that in Python, it kind of can be seen as an omission of incompetence, right? Like, and people could like, hey, this guy, he's not very smart, he's not good at what he's doing, right? Like, but here's the thing. If I say, hey, I didn't know that, I'm gonna go learn it, right? Okay, one phrase that I really like is, um, you're stupid for a minute, but smart for the rest of your life. Whereas if you don't ask, you're smart for a minute and stupid for the rest of your life. See, so I really like this kind of attitude of like, hey, yeah, I don't know this. I should know it. I understand it's basic, but I'm going to find out, and I'm not going to be embarrassed by the fact that, hey, I don't know this. Right? Like that's something that um I try to do. So yeah, I didn't know that you can pass in parameters. I just saw it just now, right? Like in my last video, or the one that I didn't post, but I was working on this a little bit because I was getting all those compiler errors and stuff like that. And so I saw it, right? But I didn't consciously like recognize that, oh, I'm passing in parameters. This is the first time that I'm looking at it and I'm like, oh wow, I guess I am passing in parameters. I didn't know I could do that with Python. That's actually pretty important. How does Python do that? How do you capture it, right? Is it args? Is it like what's going on here? So that's a very interesting thing here. So anyways, we're passing in something called model, and that is lnet. Linet. And I also do know Linnet because I models and then Linnet.py right here. Okay, so I do know that there's I cheated a little bit because I when I was doing all my debugging, uh, I saw this Linnet, and I did copy and paste this from GPT as well. Copilot. Anyways, we're coming back here. So I'm passing those into train.py. Let's go to train.py. Is there a way to get it to like, there we go. Okay. I didn't want to, I wanted it to stay there permanently. Okay, cool. So I guess the question is, how does it capture it? Let me see. What am I passing in? Model, right? Model, yeah. So Linnet model here and data set. Okay. So in train, I have model here equals Linnet. So I'm trying to figure out like training set. Are we seeing anything that says training set? Let me do like control find. It was training set, right? Or data set. Okay. No, it's just data set. Okay, so we're doing. So I'm trying to figure out when I pass in those parameters, how does it actually capture those parameters in Python? And that seems like a question for GPT. So let's ask it. Here is my, and what did I call it? Just what train.sh. I am noticing that I am passing in parameters into my train.py. Can you explain how these parameters are captured within my Python script? Okay. I probably should not be drinking coffee this late, but I'm not drinking, I'm sipping. It has to think. See, I asked a good question. It's thinking a long time. That's what it means, right? It can't be that I have a bad Wi-Fi connection. No. It's that I just asked such a good question. It's just, Okay. Anyways, while that thinks, I can look at that to kind of see when it finishes. It's taking taking a long time. Anyways, so let's just assume that we're passing in the parameters, and maybe when we investigate things, we'll find it. Anyways, but okay, so what are we doing? So we come here and we're going to run this main file. Okay, cool. So we come here, we run this, we do this get imnest data. Okay, and this was a function in here. So this one is very familiar to me because this was the thing that was causing me all those problems. And in particular, it was this line right here. Like I was the one who added this line because it kept, when what was going on is I was trying to get the actual data set here. Okay, so I'm trying to get the data set in this line of code, but it was coming back to me and saying, hey, I don't have the authentication tokens. And I couldn't figure out, like, what on earth is going on? Why do we need authentication tokens? How is that working? I had no idea about what was going on. And so I was having a conversation with Copilot, right? And I was trying to say, like, I can't fix this. I can't. And he kept giving me different random suggestions. I was like, it's not working. It's not working. And then I said, is there a way to disable the SSL, like, authentication protocol or whatever it is, right? And I said, oh, yes, add this line of code. So I put that line of code in there, and then it started working. And then that's when I stopped the last video and I said, okay, I'm going to take a little bit of a break. I'm going to just relax my mind a little bit. I went out for a walk and came back, and now I'm here. And so, yeah, this line of code is very familiar to me. So, and this guy is still thinking, let me actually just copy and paste, or copy this, then refresh the page. Probably some kind of, is it like out? No, it's not out. Oh, okay. All right. So, certainly, when you run a shell script like train.sh and pass parameters into your train.py, the parameters are typically captured in Python args parse module. Okay. This module provides a way to handle command line arguments in a more organized and user-friendly manner. Here's a basic example of how you might capture those parameters. Okay, cool. So import arg parse. I don't believe I did that though, right? Maybe, okay. So add arguments, parser dot, okay, so I'm not exactly sure what this parser is doing. I understand, like, this is some, like, it's gonna be some object or some class, right? So I'm getting an object and it's initialized with, I'm assuming that this is just like initializing a generic arg parser class, okay? And then there's a method within the arg parser, which is add argument. Not sure what that does right now, but anyways, args, where did we get args here? Oh, we're just creating a variable, args. So it doesn't seem like it's actually, let me just copy and paste this code in here and see, like, here is my code. I am not seeing any location where they are interacting with arguments. Oh, here's my code for train.py, right? what it was called? Yeah. Interacting with arguments passed in. Okay. And this is one of the reasons why I really, really like Copilot. Once ChatGPT got released, the original ChatGPT, like 3.5 or whatever it was, I was just so blown away. Not in terms of like, oh, it can write something and get it immediately correct, which, I mean, now it's getting pretty good at it, right? But the reason that I love it so much is that you can ask it questions and it responds, and then you say like, actually, I still don't understand. Can you explain? And then get it very specific, very granular, and you're able to like hone in on those exact things that you don't understand. Whereas if you're just Googling things, good luck trying to find something very specific, right? Like you see something on an article, some engineering article, and you read it, and you're like, well, I understood like 60% of it, but there's still 40% that I don't understand. Well, good luck asking a question like, hey, I don't understand the other 40%. Good luck, right? Like, okay, you just don't understand 40% of that article. And then you have to go look at a different engineering whatever, Stack Overflow or Raspberry Pi documentation or data sheets or something like that, and you just have to like keep looking at these massive amounts of data and just trying to search and get that 60%, then spend a 5 hours and now you're at 65%. And it's like, whereas with GPT you're able to say like, oh yeah, I don't understand these sections, can you explain that? And then it explains it, and now you're at 70%, right? And then you say, hey, like, okay, well, I still don't understand this part of your updated suggestion. And then you just like that down into it. Anyways, so let's do that. Got it. You're right. The current code snippet doesn't have any connection to the arguments passed in via the command line. Let's fix that by integrating the argparse module to utilities, the specified model, and dataset arguments. Here's how. Okay, so as of right now, I'm not interacting with the different arguments, which makes me curious. Like, what if instead of doing this right here, what if I actually did just run the script? Let me try that then. So train.sh. Let's see if it does do anything different based off of the different arguments. I also, as of right now, might be going a little bit into the weeds, and I might need to make sure that we can keep investigating this project, and then maybe we'll kind of stumble upon our answer regarding the values passed in. Okay, so here should be like for the mnest, right? So let's close this, and then it should run the second script probably. Okay. Okay, so now it's running the second script, and it's running. There's no like crashes, which is nice. And so yeah, I guess it's doing the VGG16 model. I don't know if I can guarantee that it's actually doing that model though, so that's kind of like the thing. I'm not sure about that. Let me go back to train. Okay. So I pass in model here and model.train. Okay. So I mean, this looks suspiciously similar to the other one that I was doing, right? Like, let me just crash this, like, there we go. So those two plots looked suspiciously similar. But anyways, let me see. Model equals Lynette. So I might always be doing Lynette regardless of the parameters that I pass in. So this is probably actually something that I do need to fix. I have an idea of how I'll do that is I have this like Lynette.py, right? And that's in my models. Now, what I could do is like use that arg parser, right? Wherever it went, args parse here to then do like an if statement. So if I pass in the Lynette as model, so like if model equals Lynette, then I run this line of code that instantiates this Lynette model. Otherwise, I do, what was the other one? Like VGG16 or ResNet18. So from that, I can like instantiate a new model. But for the meantime, actually, I think it's kind of interesting. Like, okay, I'm instantiating this new model. Like, they're this Lynette model. Like, what's actually happening? So let's look into this. I'm getting an object back. Okay, and I know from my Java uh, YouTube video series about kind of instantiating objects, right? Um, so this has its init function here. Good. And so this is kind of like how we're creating um, the object. So this is going to be this model that we get back. So we're going to have like this object is going to have parameters of is this like convolution or I'm guessing it's like convolution, I don't know. 1 and 2 FC, whatever that is, FC2, FC3, okay? So then I also do this super, which I know that this has like inheritance. This means inheritance here. So I am also getting the functionality of whatever this is. Like this is called Lynette and this is Lynette. When I call super, does it do it on an in module? Okay, so let me come here and I'm going to ask it here. So let's figure out like what's going on here. This is the code in my Lynette.py file. Can you explain what is going on? So first I'm just going to get kind of like a general overview and see what it says is important. Then after I see what it says is important, I'm going to ask my questions about the specifically make sure that I understand this super like inheritance thing, like what's it actually inheriting from. And then I also want to know like, okay, there's this function here called forward. Do I have access to it? Can I do like model.forward? So, like I understand that I am creating these member variables and I can access these member variables within my model. So I can do like model.conv1, right? Can I do model.forward? Because I'm not explicitly declaring it in the initialization function, right? And when you do the when you do this, it just runs the initialization function, I think. Okay. So, absolutely. Linnet class is a neural network model designed for image classification tasks, specifically inspired by classic Linnet 5 architecture. Okay. It's composed of several layers, including convolutional layers. So it is convolution. For all the electrical engineers, that is a trigger word right there, convolution. Pooling layers, okay. And fully connected. So I'm guessing FC is fully connected. All functioning together to process and classify images. Here's a detailed breakdown. So this is kind of the... Okay, so this is the model for how it works. Anyways, so forward convolutional layer 1 plus activation plus pooling. ReLU. So I have F. What is F? Torch neural network dot functional. Okay. So this, I'm getting some functionality from this like Torch neural network. And then I'm able to like perform ReLU, which I know is a like neural network like technique. And then I'm passing in something which is self dot conv1, so convolutional 1. And then I'm passing in x, which is a parameter. Okay, so I'm guessing that this x is probably going to be like some kind of vector. Okay. So here's pooling. Okay, something about pooling. And then ReLU. So I'm just capturing this x and just changing it. I keep putting it here, and then I get it, and then put it here and here, and then I return it. So I do a whole bunch of like things. I don't know what's actually happening, but things I'm going to say to x, which I don't even know what x is yet. And I am using that to change things and then return it. Okay, sure. So let's come here. Class definition and initialization. Your init class inherits from in module. So that's probably, so we have here, so I guess that is kind of the parameter. It takes in its parent class, I guess. Okay. And then, which is the base class for all neural network modules in PyTorch. Okay, so which is the base class. So I guess class means like model, maybe? The init method defines the structure of your network by initializing its layers. Okay, so we're initializing layers. So linear layer, linear layer, linear layer. And we're passing in some parameters. Passing in other parameters, okay? So convolutional layers, convolutional layer with one input channel. So grayscale here. So there's one input layer. So this one has 6 input layers, I guess. Okay. I'm also noticing, look at this, 6, 6, 16, 16, but then times 4, 4, okay? But then 120, 120, 84, 84. So I'm guessing that this is like the input. So the first parameter is the input, and then the second parameter is the output. So I know in neural networks you have the number of inputs. You have a whole bunch of different inputs, and then you have a whole bunch of different outputs. And then you can connect them together. So like one node can have one input and then 6 outputs. I think that's what's going here, like six outputs, 6. And then you are feeding that, like I'm guessing that we're going to be feeding that into the input of this second layer here. And then likewise, this has 140 output, or 120 output, sorry. And that is going to be fed into here and this output and like that. So I'm guessing that that's kind of what's happening. Okay, so now def forward. So getting this passed in as F. Okay, let's keep going. So convolutional layer with input 1 channel grayscale, 6 output channels. Yep, there it is. And 5 times 5 kernel. Not sure what a kernel is, but okay, that's that one right there. So fully connected layer that takes the flattened output of the convolutional layer and maps it to 120 features. Okay, fully to 84 features. So this one, okay, this is 10, and that corresponds to the 10 out. So this is the output, which there's 10 classifications. So the MNEST dataset that I'm going to be using is hand-drawn numbers, and these hand-drawn numbers are 0 through 9, and so there's 10 classifications that it could be, and so that I think is going to be the output of this FC3. And if I look here, I see self.fc3, and I'm passing in x, okay, and I get this x back, so it's going to return 10. So if I have to guess, right, what I would guess is going to happen is x is going to be a vector of size 10 corresponding to the probability that the input, which is this x, this inputted x, is of type whatever, like 3. So you're going to have 10, and the 0th element is going to be the probability that the input here, that you passed in a hand-drawn number that was 0. Then the second index is going to be the probability that the hand-drawn number is a 1. And the third is going to be that the hand-drawn image is going to be a 2, right? So, and then it's just going to go all the way out there. So I'm guessing that's going to be what the output is. So like a 10, an array of size 10, each indice is corresponding to the associated probability of its respective number being what was drawn, or number minus. No, it would just be number because it's 0 indexed. Both are 0 indexed. So 0 corresponds to the probability that it is 0. 1 corresponds to the probability that it is 1. 2 corresponds to the probability that it is 2. 3 corresponds to the probability that it's 3. So it's not off by 1. Never mind about that. So I'm guessing that that's what happens. I don't know. I'm just looking at it. So, okay. So I pass this through PyTorch's ReLU functionality. And what do I pass through is a convolution. So I'm passing in whatever this is, and this is also a PyTorch. So this is just like setting up the parameters, I think, right? So I guess why I'm confused is this is setting up parameters, but then it takes in an argument. So and then I apply a ReLU. Okay, let's look at the pass forward. So apply the first convolutional layer, followed by a ReLU activation, and 2 times 2 max pooling. Second, okay. Applies ReLU, apply nonlinear, and help the module learn complex patterns. Okay. It's just gonna take me up to here. Go to definition here. Okay, so this takes in something here. Okay. Self.init. Okay, another interesting thing that I'm seeing in Python is I didn't know that I can have this like arrow operator. Oh, that's a return type. Never mind, I didn't know it. Okay. It's not. Okay, that never mind. Never mind about that. I was thinking like, oh, is this like JavaScript? That's cool. Anyways, so self, and then these are the parameters that I could pass into it upon initialization. In channel, out channel. Yep, in and out. Kernel size, we saw that as well. Biasing. Okay, and then it returns none. Okay. Super init, and so this, it inherits from something else, which what does it inherit from? This one, the underscore con in D. Okay. So then, let's see, I have this. Is that what we did? Conv 2D. That is kind of. So here, okay. But I'm doing self.conv1. So I'm just calling that. I have a variable, a member variable. How do I call a function on the member variable, right? Like, what? What? Okay. Let's ask about this. So I understand these two lines of code. It seems as if I am initializing an object that is being stored in a variable called conv1, but then I am calling conv1 and passing a parameter of x into it like it is a function. Okay, I see how it might look a bit confusing. That's the magic of object-oriented programming. This is another very good thing that I'm doing right now, is trying to understand what object-oriented programming is, because I didn't really, I haven't touched object-oriented programming, which again, I shouldn't admit, but when I did C, when I did C++, it was essentially C inside of C++. So I was doing to me, it was the exact same language. The exact same language. Exact same functionality. I never did any of those, like, I never saw that C++ even could be anything other than C. And then very recently I saw, like, oh, actually, C++ has significantly more functionality than I thought it did. And I'm like, oh. And then when I got into my YouTube project video of Java, I realized, oh, I really don't understand what's going on with object-oriented programming methods. Not methods as in, like, not methods as in the CS term, but I mean, like, methodology. Okay, so let's look at this. So, initializing a convolution layer. So that's this line of code. Yep. Cheers. It's 10 o'clock and I have to work tomorrow. I really shouldn't be drinking coffee. But it helps me. Gives me power. Okay. This is a class attribute. You are creating a convolutional layer and assigning it to that variable. Yep. This is a PyTorch module that defines a two-dimensional convolutional layer. The number of input channels. Okay, the grayscale. Yeah, so I'm okay. Essentially, you've just created a convolutional layer but haven't applied any data to it yet. Okay. I don't know, like, I created a convolutional, so I mean, I did this, right? Like, so I'm taking in a whole bunch of okay, the way that it's written is kind of like this bracket, or this parentheses, is corresponding to this one. So all of these are arguments to the init function for this class, this conv2 2D class, okay? Its parent is this conv in D, which is also like a class but defined somewhere else, okay? Then it returns nothing, which it kind of looks like it's returning something, right? Like, okay. So then there's the colon. So this is the actual function that is run, and we're just initializing. And I'm also noticing it's not doing like self dot factory kw args. It's doing just like factory kw args. So it's not like self or anything. Okay. Limit here. So line 2, applying the convolutional layer. So here's where the magic happens. Even though self.conv1 is an object, it's also callable, like a function, when you call x. It performs the convolutional operation on the input tensor. X is usually a batch file. Okay, so after the convolution, we apply ReLU. So I understand that. We take this output and pass it in as a parameter to ReLU. That kind of makes sense. Okay. Where would, how is it possible that we are able to call it as a function? Where is this functionality defined? So the ability to call a PyTorch level object like a function comes from how PyTorch in class and its subclasses are designed. So behind the scenes, underscore, oh, I know these are called dunders. Dunders, because, okay, so anyways, so dunder call method. In Python, the call method allows instances of classes to be called as if they are functions. When PyTorch layer inherits from an in module, it inherits the call method. Okay. So I'm inheriting this call. Okay. The call method in module is designed to automatically call the forward method. This is where the actual computation happens. When you create a layer, like you're creating an instance of a forward method. Okay. So init self, yeah, super, yeah, my module self. Is that kind of Lynette self? Okay. So this Lynette is the class type, right? It's just your class, my module, and then self. And initializing the init function of the parent. Okay. Self.layer, which is here. So I'm just returning, I can return that. I could return, like, it's just doing this, like, here, layers, or layer, passing in X, okay? So I guess when I do that, it just, okay. Let's see what it says here. Instance creation. Model equals my module, okay? Calling the model. Output equals model input tensor. Okay. So model, calling the model where? Where am I calling the model specifically? Oh, here. So model equals my model, yeah. Output equals, so, okay, yeah, here. The input tensor, okay, so I'm passing in a tensor. This triggers model dot call input tensor, okay? Model, which is here. So model, and I have input tensor. Trying to wrap my brain around how all this is working. So I'm calling, I have model, which is an object, okay? And this is the object right here. Like, this is the class. And I'm able to just call model, okay? And model automatically is able to, so it just automatically triggers this like underscore call, okay? And it takes in the input tensor. Good. This call internally calls model forward. So it's model.forward with the input tensor, okay? Now, forward function, return self.layer, layer calls self.layer call. Okay. So layer call, this one also must have a call. So, okay, I think that both of them have like dunder calls, but they're different dunder calls. I was thinking maybe it was like recursive or something. So this one here, this my module inherits from in module, and this in conv2, when I do that, inv conv2 inherits from this conv in d parent, and this one must have a different call, right? Like, can I go to definition? Can I go to definition? So here, Like, I'm not seeing dunder call. Okay, well this inherits from module, so let's go to module. Okay. Okay. Init here. And module seems like it has no parent. Module has no parent. Call super. Call init is false. Okay. Whew, there's a lot going on here. Okay, module. Training is parameters is callable. Have these callable things. Call super init. Okay. Oh, here we go. Here we go. Here's dunders, right? Any. I know ... means it can take in like as many parameters that are actually passed in. Hey, here's these args and k args. That's kind of what we were talking about at the beginning of this video. Okay. I'm not seeing underscore call immediately right now. Okay. So apply CUDA IPU CPU float double half overloaders. Convert. Here's something of call. Doesn't look like it. Okay, so here's more. What was that? Get state, set address. Guess I could just do like Control F. If I don't see it here, I'm gonna just do Control F and see if it's even in here. So now we're at the end. So yeah, let's Control F this. This module call method is compiled and all arguments are passed as in. Compile this module. Is that okay? So there's 3. Wait, compile this module. Why compile? Python is not compiled, right? Okay, so there is a... What on earth is this? I actually might have been looking at this. I think I actually was looking at this. But anyways. This was found within the module.py of the in dot So anyways, back up to here and then we'll look once it's done. So I think that there's two different calling functions. Or maybe it's the same function, but it's instantiated twice, I think. And that means that it's different, so it's not recursive. So when I do this, it's calling this one's call method. When I do this one, it's calling this one's call method, right? And so somehow it automatically just looks for forward, maybe. Now that offers another second interesting thing. Like, does this one, this conv2, does it have a forward method itself? Here's this forward. Yes, it does. It has a forward as well. Okay, so forward must be kind of like a keyword is what I'm getting, kind of. And so whenever you call that, like call, or invoke that call function, it just automatically does this forward. And then it runs this code, which is calling a method, which is up here. Okay. Anyways, okay. So I kind of understand this. I think it's getting a little bit late. So I think what I'm going to do, I still have to do a LeetCode video because I promised that I am going to do one LeetCode video every single day. I've been working on this project literally all day today. So I am going to stop it here. I'm going to be making another video continuing my progress on these neural networks, and I'm going to keep digging into this project right here, keep trying to learn it, keep moving forward, because we barely scratched the surface and I still have no idea what's going on. I don't even know if it's actually working. So that's going to be continuing the investigation moving forward. But right now I'm just looking for interesting topics of kind of like, oh, like I have no idea what's going on here. This seems pretty important to either whatever software engineering or Python or object-oriented programming, which is what we got into today. But anyway, so yeah, if that is something that is interesting to you, I would love if you would subscribe to this channel. That would be awesome, and I will be making more of these machine learning PyTorch videos, and yeah, continuing my other projects as well. Obviously, LeetCode, as I said, doing one problem every single day. The other ones are the JavaScript projects and the Java projects. So anyways, thank you guys so much for watching. My name is Timothy Lee Grant, and I will see you in like 10 minutes because I'm going to be doing a LeetCoding video. So see you then.